Last time, we spent some time taking questions from Chapter 4, and then starting Chapter 5, right? Did we talk about the test format last time? Okay, well, let's take a few minutes and do that right now. So what we're looking at is in the content library under Chapter 4. So this is the test format. So the first two questions, we're just using our calculator to find the value for an inverse. It's literally like, can you type this into your calculator and press enter and write down the number? Two questions where we use the unit circle to find the exact value for the inverse. That's like question 1 from the first page of the review. Two questions where we want to find the unit circle to get the exact value of a nested inverse and trig function. So that's like, oopsie daisy. These questions on page 3 of the review. These ones right here. Okay with that? FYI, these ones were like type in your calculator questions, right? Where were we at? One question where we want to find the algebraic expression for a nested trig and inverse trig function. So that's like the worksheet 4, right? One question where we use the calculator to find the inverse over a specific interval. That was like worksheet 2. Was all the questions about that. We have 2 story problem questions, and then one of these navigation bearing questions. This is like the first question on the review.
Same with the first one too.
That's like the second question on the review, I think. Yeah. So that's using the unit circle to get exact values. That's just using your calculator. Any clarification or question about these things here? Okay. Any other Chapter 4 stuff you guys want to talk about before we get moving along? Mr. Frost, we'll start with you. Number 2 on worksheet 7. Okay, so John Rambo leaves base camp at a bearing of 38 degrees and goes 4.6 kilometers, turns at a bearing of 311 degrees for 6.7 kilometers. Then he turns again at a bearing of 128 degrees for 9.8 kilometers. How far is Rambo from the base camp and what is his bearing? Okay. So when I read this, I just hear like basically we're taking a trip and we're doing 3 turns on the trip. So there's like 3 legs to our journey. So the first leg, our bearing is 38 degrees. So that's that. So the standard form angle is going to be this one. So 52 degrees. So my pen wants to work. My distance is 4.6. So if I break that into a horizontal component, I have 4.6 cosine 52 degrees. And a vertical component, that's 4.6 sine 52 degrees. If we look at the next leg of our journey, that's 311 degrees. So over here somewhere, 90, 180, 270, and then 41 more, which means this is 49. That's 90, so our theta here should be 90 plus 49, so 139. The distance on that is 6.7. So 6.7 cosine 139. And then the horizontal is 6.7 sine 139. Doing okay so far, Paul? Okay. And then our third leg, we got a bearing of 128. So we're down here. So 90, 38. So this spot must be 52. So 90 plus 90 plus 90 plus 52 is 322. And the distance there was 9.8. So our x component is 9.8 cosine 322. Our y component is 9.8 sine 322. Okay. So our final position then is just going to be the sum of the x positions and then the sum of the y positions. So we'll go to our calculator to do that. Make sure I'm in degree mode. That's good. So the x is 4.6 cosine 52 plus 6.7 cosine 139 plus 9.8 cosine 322. So that's 550. And if I do the same thing with the sines then, oops, too far. I get 1.99. So far, so good. Okay, to get the distance then, I'm just using the Pythagorean theorem. So I'm just using that point that I found. Whoa, doggy. I did something there. So I get 585. And everything was in kilometers then. Still doing good?
Yeah.
The last thing I need then is the bearing. So if I plot the point 550, 199, and draw a line from the origin to that point, that's going to make up my terminal side, right? So my bearing goes from north so that angle there is like my alpha. So my bearing is going to be 90 minus alpha, where alpha is going to be the tan inverse of the absolute value, yf over xf. So 90 minus tan inverse. I'm dropping the absolute value when I'm typing this into my calculator because both y and x were positive, so that doesn't matter. Or you can think about doing it in your head, whatevs. So I get 70.13 degrees. Does that feel okay, Paul?
Yeah, it's just maybe that's hard.
So it's still the same thing as we're doing on from like worksheet 2. The only difference is when we're drawing our answer, we're using the bearing, so starting at north and going clockwise, as opposed to be starting on the positive and going either clockwise or counterclockwise, depending on whether my answer is positive or negative. But here I know my answer has to be between, we know exactly where it lies from the point. So the drawing the terminal side is easy. And then it just, you're adding or subtracting alpha based on the same set of rules. Does that feel okay?
Yeah.
Okay. Aria? Because you're asked for, like, what did you start out doing? Yeah, because it's asking for what did you start out doing, or what was one of the initial conditions, rather than asking for like, okay, this happens and this happens and this happens, where do you end up at? That's an addition problem. It's like, okay, you ended up doing this, and this happened, what else would have happened, had to happen in the beginning? That's a subtraction problem. That's why you would be subtracting. Does that make sense?
Are we going to get a subtraction?
Well, I don't know. Probably not. Tommy?
On the review packet, can you do question 4E?
What page are you looking at?
I think it was 2. Question 4.
This one? This
No,
page?
No, down one. Yeah, and then E from that one, please.
So I need the unit circle to go with this. Okay, we're going to work from the inside out. So I'm going to start by doing tan of 5 pi over 4. So I know that tangent is y over x. So I'm going to go to my unit circle and retrieve the x and y coordinates at 5 pi over 4. So that means what we're really doing is arc cosine of 1 then. So I remember that the range for arc cosine is between 0 and pi. So I'm going to go back to the unit circle. and I'm going to look for where cosine theta gives me 1 between 0 and pi. So here's 0, and here's pi. So I'm going to look for where the x-coordinate is 1 in there. The only place where that occurs is right here at 0 radians. So the answer there is just 0. Is that okay? Okay. Luke? So this is a calculator problem. I know it's a calculator problem because when I look at negative 98 degrees, that's not a unit circle angle. So I'm going to work from the inside out. Now, sine of 98 or negative 98 degrees, what mode does my calculator need to be in to do that? Degrees. It's not a trick question, right? If we're doing sine on something in degrees, your calculator best be in degrees. So let me check that, okay? So I'm just going to do sine of negative 98 degrees. So that's my value. And then it wants me to do arc sine of that answer. But the directions ask for my angle or my answer, my angles as radians, right? So now I'm just going to change my calculator mode to radians. So when I do sine inverse, it gives me my answer back as a radian. Is that okay? So I get negative 143. That's my answer. How's that sound? So that one was tricky because you had to change your calculator modes so that it would do what you're asking it to. If you were in radian mode and you tried to do that, you probably said uh-uh. Or if you're in degree mode the whole time, it probably said uh-uh. So you have to be a little bit careful there on that one. Blake, did I see your hand up earlier?
Yeah. How do you do for 4 on worksheet 7? I have an answer that's wrong. So I guess I don't know.
I mean, you do it the exact same way as we did for number 2. Yeah, just 3. It's just an addition problem with 3 things.
Okay. So it's just addition.
Yep. What part are you not getting correct?
The final point, I'm like 0.3 off.
Okay. It could just be, did you do it all in one line on your calculator? Or did you do it as like 3 separate pieces and then add the 3 pieces together?
I did it as one line probably.
It should have just come up. It might be just like a little typo or whatever. Or maybe you just like 1 degree is wrong or something. Like you might have written like, instead of writing 64 degrees, you wrote 62 degrees or something silly like that.
Yeah.
That could cause it to be off just a little tiny bit. But, do you need me to do it?
No, it's all right. I
mean,
was wondering if it was an addition or subtraction problem.
It is a
That's
100% an addition problem.
But then the next one is a subtraction problem.
Yeah.
Okay.
Yeah.
Gotcha.
Yeah. Again, because it's asking at the end of the day, like, what is the resulting?
Yeah.
That's asking for overall. So that's you added some stuff together and you're looking for the final.
So then that's asking for your
Like, what should we have taken? That's an initial value. So that's your key. Right? Like, if I had 5 apples and Phil gave me 3 apples, how many apples did I have to start with? That's a subtraction problem, right? Or you know the result and something that happened to get to the result, and you're like, what was the beginning? Subtraction. It's like I had 3 apples, and then Phil gave me 2 apples. How many apples do I have? That's an addition problem, where you knew the starting conditions and you're asking for the end. I don't mean to be reductive about it, but sometimes it's like we just need to like simplify the problem into a way that's like, oh, sure, like adding apples and subtracting apples. That's like, I for sure get that. And you can see the same thing going on here. Because there's a lot more words in this problem, clearly. But that's the way that I'm looking at it. It's just going back to like elementary school adding and subtracting story problem. Because it's still kind of the same thing. I mean, it's wordier, for sure. And it's clearly a much more complicated idea. But if you can pick out the adding and subtracting, like that's all we really need to, they're all the same if you can square that part. You know what I mean? Blake?
I do have another question. For question number 2 on page 1 of the review sheet, so I thought that inverses only dealt with side measures, don't they? Or do they deal with angle measures too?
Which one are you looking at?
Let's just say E, letter E, of the bottom section, not that one.
Oh. Right. That's correct. So it's the tan inverse of negative 66.75 degrees going to be?
Would you just throw that in your calculator?
It's undefined.
Because it's an angle measure.
Yeah, because it's an angle measure.
Okay, so that doesn't work.
Yes, correct. You could say the same thing about D, right?
Yeah.
The tricky thing here is that if you typed sine inverse of 37.5 in your calculator, it says undefined. It says domain error.
Oh,
If you type tan inverse of 66.75 in your calculator, it doesn't give you an error.
Okay.
Because the domain for tan inverse is all real numbers. But you have to be putting in a real number measure, not an angle measure.
Yeah, okay,
So that's why those 2 problems are back to back, because the calculator gives you an error immediately on one, but not the other, even though they're both undefined. Because you can't do an inverse on an angle measure.
Okay, perfect. That's what I was thinking.
Yeah. H is also undefined as well. And F.
Wait, H is?
Yeah. Because the domain for sine is -1 to +1.
Yeah, yep.
So you have a value outside of the domain. That's why that one's undefined.
Got it. Okay. I get that.
So these are just like, type it in your calculator, but you have to like make sure that what you're typing in your calculator is actually not a bunch of nonsense. You know what I mean? If I tell you to do, 7 plus square root symbol, you should be like, that's a bunch of caca-boo-boo. Same thing here. Luke.
So, for C on the 4.01 continued
Whoa, boy. What page are you looking at real quick?
one down, and C.
This page?
Yep.
Okay. You just did that real fast, and I was, I was listening, but apparently not well enough.
So, in order to get those measurements to actually be on the on the unit circle, couldn't you just subtract 3 pi over 2?
No,
Okay.
because it's not. You're not subtracting an entire rotation.
So you need to subtract the whole entire circle.
You need to if you're going to do it that way, you need to subtract multiples of 2 pi.
Okay.
I do not like to do it that way. I just count around, which I think I'm much less prone to make an error if I'm just counting around. But if you're going to go that route, that's fine. But it needs to be, if you're adding or subtracting something, it needs to be a multiple of 2 pi. Well, like 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, 14 pi, 16 pi. something, an even amount of pi's.
Yeah. Okay. And then could you
My way or your way?
uh,
Okay. So I'm going to go just observe that theta is positive because it's between two positive numbers. So going around my unit circle, we're starting at 0, half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. So we're looking at something between 7 pi over 2 and 9 pi over 2. So we're looking at quadrants 1 and 4. Consulting all silly turtles crawl. I know sine is negative between quadrants 1 and 4 and quadrant 4. So my theta then is that. My alpha is here. So my theta is going to equal, because the part of the x-axis that makes up my alpha is 4 pi. Theta is going to equal 4 pi, because the last axis I pass through when getting to the terminal side is vertical. I'm going to be subtracting alpha, where alpha is just going to be the sine inverse of the absolute value 0.45. I'm sorry, negative 0.45. But whatever, absolute value, crush the negative anyways, right? So got to go make sure I'm into radian mode. And I just do 4 pi minus sine inverse 0.45. So I get 1210 as my answer. The part that's stinky about doing it the way that you're doing it for this particular problem is you'd really want to subtract 4 pi there, but then you end up with one part of it negative and one part of it positive. And the answer you're actually looking for is in the negative part, which makes everything, like, I think, more confusing than it needs to be than if you just kind of count it around and do it the same way every time. But
could you just convert that into?
I mean, sure, it doesn't really make it any different, though. Because the hard part is deciding what you're going to be adding and subtracting from, and then whether alpha should be added or subtracted, right? You know, at some point you're going to have to do sine inverse of 0.45 or negative 0.45. But, like, you know, do I need the absolute value? Do I not? Does it need to be adding that to something or subtracting it from something? And what's the something I'm adding or subtracting to? And, like, the way that I'm doing it, that answer is like, you do it the same way every time. You know, it's like, okay, last thing I passed through was horizontal or vertical. My answer is positive or negative. I know that all from my picture. So the equation just comes like spilling straight out from that. And doing it the other way, you can run into like weird situations where like half of your interval is positive and half of it's negative, which is fine, but it kind of makes it a little bit awkward to get the answer out of.
And so, in order to like try to get that angle early, we counted the radians doing counterclockwise.
Correct.
When do you go clockwise?
If my answer is negative, right? I know right now the answer I'm looking for has to be between two positives. So I know I'm going clockwise because I know my answer has to be positive. That's one of the complications if you subtracted 4 pi. Half of your interval is negative, half of the interval is positive. It's not entirely clear whether you have a positive answer or a negative answer implied from that. You know what I mean? Which is like, ugh. The one advantage of that is you might observe that was the negative pi over 2 to positive pi over 2 is the fundamental range for sine. So you could type it just directly into your calculator and be fine. Sine inverse of negative 0.45 and just be done with it. But that would be a lot to ask I think, from you making that making that observation here this time rather than like doesn't happen all the time. This was just like a weird special case where it could turn into a really easy problem, but like noticing that is a big ask, particularly in like a stressful test setting. I don't know. Did I help you out?
Yeah, okay.
Okay. Sometimes I just feel like I keep talking because I only see this much of your face, so I can't really tell, like,
Yeah.
is this person kind of smiling at me like, oh yeah, I get it? Or they're just sitting there staring blankly at me like I'm still freaking confused and you keep on talking and it's not making it any better. So I sit here and doubt myself and just keep talking sometimes. You guys get it, I'm sure, right? You've had a year of masks. It feels like forever of masks. Anyways,
Been quite a while.
it does feel that way. You think that there's going to be a kid that's going to graduate from high school without ever having taken a mask off?
Oh man.
Like, there's people that are halfway through, right? If you're a sophomore now,
Yeah.
so far all of high school has been masked. Do you think you're going to have 2 more years of masks in high schools?
No.
I don't know.
I didn't make that.
Oh, that's true. There was the beginning of the year was not masked. That's true. It was a good 2 weeks, right? Or 3 weeks.
No, this time last year.
All right.
Yeah, that made me really
Anybody else with chapter 4
I didn't know it.
questions before we move on here? Yes, Amanda. Did you, what number on the problem set? Okay, sure. I thought at first you said 41, and I'm like, I must have misheard that because I'm pretty positive there wasn't 40 questions. Okay, so if I read this, this is a subtraction problem, right? Because it tells us, like, what we end up doing, what did we start with? Do you kind of read that as well?
Yeah.
Okay. So, like, I know that my plane initial is going to be the plane final minus the wind, right? All right. So my plane final, the bearing is 120. So 90 and 30 more. That makes 60, 90, 90, 90. So our theta there is 330. Speed is 500. So x1 is 500 cosine 330. And the y1 is 500 sine 330. And the wind, 130 is the bearing on the wind. So like right there, so 90 and then 40 more. The standard form is 90, 90, 90, and then a 50. So that's going to be 320. And the speed on the wind is 30. So x2 is 30 cosine 320. And y2 is 30 sine 320. So my initial is going to be x1 minus x2 comma y1 minus y2, right? Okay. if you don't like anything I'm doing or you're confused, make sure that you holler at me. You are, Amanda, currently in like, there's like 16 heads in my line of sight of you, so I'm trying to look for you, but sometimes it's a little tough. So if you're like trying to say something and just being kind of timid about it, just don't feel like you need to do that. Just get loud on me so I make sure that I notice what's going on. So I typed in the sine and cosine, or the x1 minus x2 and the y1 minus y2 into my calculator. So I have 410.03 and then negative, what was the other? 230.72. You good there? Well, let's make sure that I typed it in. So 500 times cosine 330 minus 30 times cosine 320. So it looks right. Is it possible that you did something silly and put like the subtraction or the negative symbol instead of the subtraction symbol? That would get you a goofy answer there and be tough to catch if you weren't if you didn't know it was the wrong answer. You know what I mean? That's one where you look at it and be like, I don't see what I did wrong. Anyways, continuing on. So then to get my speed initial, I just do the Pythagorean Theorem. Again, when you're typing this into your calculator, you got to be careful with the negative there, right? You got to make sure that those negative parts are in a parenthesis in your calculator, else the calculator is going to do what you told it to instead of what you meant it to do, which is square it and then make it negative, as opposed to make it negative and then square it, right? I saw somebody the other day talk to me about, like, why is this not working? And I had to break it to them that they were typing it into their calculator wrong. They were like, oh. I was like, yeah, it happens. So there's that. So far, so good? Yeah. Okay. And the last thing I'll do here to get the bearing, I'm going to plot 410 to the right and then 230 down. So that's my bearing. So 0, 90. So my bearing is going to be 90 plus alpha, where my alpha is that spot that I drew there. Tan inverse absolute value of 230.72 over 410.03. And then it's calculator time. And obviously if we ended up with the wrong y coordinate or whatever, like, that's going to be a bunch of problem, right? But you probably were doing the right technique. Now I'm going to use the absolute value here because I'm going to go and pull the values from the calculator, and rather than having to worry about dealing with the negative signs or whatever and deleting those out of there, I'm just going to put the absolute value in. So I get 110.30 or 119.37.
Yeah,
It was just that negative sign thing.
yeah.
And that I'll kick in the butt. It's like, oof. I spent probably a lot of time trying to figure out what was going on wrong. It was I put something in my calculator wrong. That's a Mr. Kulik mistake if I've ever heard one. Arya. Of course. Amanda.
Okay, also, how do you know?
So alpha is always going to be between the terminal side and the x-axis. Same the way we did it in like the worksheet 2 problems. And whether we're adding or subtracting alpha, the same rules as we used on the worksheet 2 problems. The nice part about bearings is there's no negative bearings, so they're always going to be going in that one direction only, so you can, there's not like, oh, if it's negative answer and it did this, then we do that instead, right? Like, just the same all the time. Is that okay? Okay. Again, try to keep it as same as we can, right? Let's learn one way of doing it that's like super transferable. That's the math teacher in me likes doing that. Maybe it's not always the most convenient way of doing it, but like, boy, do I like one size fits all learning. You know what I mean? Maddie.
Finding alpha is absolute value of y over x, right? Okay. I messed up that and made me get lots of different answers.
Yes, yeah. You got to make sure that you're nuking off those negatives. Now, there's ways to do it where, like, you can leave the negative signs in there, but boy, it, I think, makes it kind of a mess. And then there's a lot of, oh, you have to change it on this one, but you don't have to change it on that one. It's like, I just do it this way because it's always the same. Which, again, like, that's my preference. Like, maybe I miss a shortcut here or there, but I'm okay with that because then I'd have to actually count on recognizing that there was the shortcut. So yeah, I just need to do it the same way every time because it's not that bad once you do it a bunch of times. You know what I mean? Like once you get good at it and it's the same every time, it's just like, now I am angle finding machine. And I can just like knock them out. Like boom, 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 boom. Boom, 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 boom. And it's no big deal. So I don't really have to sit there and think about it too hard because it's kind of the same thing every time. You know. Anyways, that's me. Maybe you're not me. I bet you wish you were me, though. All right. Who's next? Happy to do more if you want. If you're done, that's okay too. No big deal. All righty. Well, I'm going to stop this.